Now we are solving question number 2 of this topic of differentiation for A2 levels. A curve has an equation y equal to sine of x, cos of x, sine of 2x. Find the x coordinate of the stationary point in the interval from 0 to pi by 2, giving your answer to the three significant figures. Y equal to cos of x into sine of 2x, and we are going to find out the stationary point from 0 to pi by 2 for this interval. Is in between these two values. So that means y equal to sine will not be there, and we are going to find out the stationary point for these curves here. We know that stationary point means we will find first dy by dx, and then you put dy by dx equal to 0 to get the x coordinate of this stationary point there. But it is the product of the two different functions. It is u, and let's say this is v. We know that dy by dx is equal to v into u derivative plus u into v derivative. So this expression will become dy by dx is equal to sine of 2x as is, and cos x derivative is minus sine of x, plus cos of x as is into derivative of sine of 2x is 2 cos of x. So this will become minus sine of x sine of 2x plus 2 cos of x into cos of 2x. Now this thing will be equal to 0, but we have to first equate it in the form of one of that function so that we can change the values of this. So minus sine of x as is, and sine of 2x is 2 sine of x cos of x plus 2 cos of x as is into cos of 2x is equal to cos square x minus sine square x. This thing will become equal to minus 2 sine square x into cos of x plus 2 cos of x into cos square x minus sine square x. This cos sine square x will be changed in the form of cos, so that is 2 into 1 minus cos square of x into cos of x plus 2 cos of x into cos square x as is minus 1 minus cos square of x for this part. This thing will become equal to dy by dx is equal to minus 2 into 1 minus cos of x minus cos cube of x. This will become plus 2 cos of x into 2 cos square of x minus 1. This will be further equal to minus 2 cos of x plus 2 cos cube of x plus 4 cos cube of x minus 2 cos of x. That thing will be equal to minus 4 cos of x plus 4 cos of cube x. Therefore, it is 6 cos cube of x. Now, we put this thing is equal to 0. So that thing will be equal to 4 cos of x minus 6 cos of cube of x is equal to 0. So cos 2 cos of x is common. It should be 2 minus 3 cos square of x equal to 0. So either this 2 cos of x is equal to 0, then cos of x is equal to 0, then x is equal to cos inverse of 0, which is equal to at pi by 2 and 3 pi by 2. But they are not in the range of this 0 to pi by 2. So these two values will be eliminated from this portion there. Then we will use 2 minus 3 cos square of x is equal to 0, or 3 cos square of x is equal to 2, or cos square of x is equal to 2 by 3, or cos of x is equal to square root of 2 over 3 with a positive negative sign there. But again, we know that our range is from 0 to pi by 2, as cos of x is equal to 2 over root 3 positive and cos of x is equal to minus 2 over 3 negative. So, because cos is positive in the first and the fourth quadrant, but fourth quadrant is not in our range, so this value will be eliminated there. And this minus indicates that it is in the second and the third quadrant, and they are also out of the range, so that will also be eliminated there. So we will just take cos of x is equal to 2 by 3 root, or x is equal to cos inverse of 2 over 3 root, and that thing is equal to point 0.62. So the value of this thing is 0.62 radians, which is within the range of 0 to pi by 2 there. So this is the answer for this question for the stationary points of these two curves there. So x is equal to 0.62 radians is the answer for this question. Since the answer is up till three significant figures, So the same answer will be written as 0.615 for the question there.